Welcome to today's webinar entitled Planning for a Modular, Scalable District Heating Loop, Key Challenges and Successes at Brown University's Jewelry District. My name's Billy Zadick, Manager of Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. Before we get started today, I'd like to introduce our speakers. We have Bob Mancini, Director of Business Development, Ecosystem Energy Services. And he is a strong client advocate, passionate about helping each achieve goals to reduce energy consumption, operating expenses, and greenhouse gas emissions in the most intelligently engineered and professional rewarding way. We have J.P. Druin, Senior Director of Project Development at JP helps stakeholders develop and implement their energy vision by reducing energy consumption and GHG emissions, facilitating operations and maintenance, renewing assets, or improving occupant comfort. As an engineer, he is passionate about finding creative and impactful solutions for complex energy ecosystems that deliver the best possible results. He offers deep experience with district energy network, steam to hot air conversions, and heat recovery applications for higher education, as well as life sciences, healthcare, K-12 school districts. And we have our final presenter today is Dave Larson, Senior Energy Engineer, Brown University, Office of Sustainability and Resiliency. Dave serves as a primary energy engineer for all planning, design, and construction projects and provides innovative and creative engineering solutions and guidance to operations and PD&C in meeting Brown's high-performance design and energy-related standards and commitments. He also provides leadership to the National Grid Strategic Energy Management Incentive Program. At this time, it's my pleasure to turn this over to our speakers for today's webinar. Gentlemen, take it away.
Thank you, Billy. This is Bob Mancini. I'm not sure, JP, can you see me yet? It says people can see you, but in the initial portion, you could not see me. Can you see me on screen now?
No, still not, Bob. So
okay.
you'll.
All right. Sorry to the group. I'm not sure if it's just warming up, and I'll pop up later. It says people can see me, so I won't be on camera for now. But would like to welcome everyone and give a big thank you to APA for always bringing good, relevant content to its members. Getting warmed up here. So Dave, JP, and I are thrilled to deconstruct and share the challenges, successes, best practices, and lessons learned that came from planning for a modular, scalable district heating loop in Brown University's Jewelry District. We included this slide to help frame up the idea that we're all working from a strategic vision to address big challenges aimed at things like decarbonization, energy conservation, operating expense savings, and aging infrastructure needs. And within the strategic vision, there's a lot of subcategories, sub-strategic planning that goes into carrying out the overarching strategic vision. We like to think of them as individual battles that go into winning the war. And with more initiatives on campus competing for limited funding and an already stretched personnel workforce, the need for an efficient, well thought out strategy for each battle is really more important than ever. Our overarching goal for today's information is to share the framework and process for how we, Brown University and ecosystem, thought through this opportunity in the jewelry district. We'll look at the actions we took for determining who should be around the table, the most important outcomes we should be solving for, all the way through to geeking out on the more technical parts associated with the solution we ultimately landed on. It was, as you can imagine, was a very collaborative, very iterative process, and one that can be modeled by every campus chasing your own strategic vision. It's very repeatable. So over the next hour, we'll be super happy if you can find one or two things from this story that will help you get closer to achieving your goals. Dave, will you take us through the background?
Sure, yeah. If you go to the next slide, just a little bit of background about why we entered into this process with Ecosystem. Some of you may not be familiar with Brown, but Brown's located in Providence, Rhode Island. The traditional original campus is up on the east side. It's up on the hill, nice leafy part of Providence, very beautiful area. But we also have had a presence downtown for about 20 years, and it had very slow growth for a while. And that area used to be south of Interstate 195. They moved the highway, and so what used to be called the Jewelry District, or you'll hear us refer to it as the JD, has sort of been transforming into a life sciences district. Everybody, I think all the folks in power would like it to be referred to as a life sciences district, but we still all just call it the JD. There was a lot of manufacturing in here and in the past, and that's the history. But this is not contiguous with Brown's main campus. And I think Bob or JP is going to talk a little bit about Brown's decarbonization goals later. But let's just say that, you know, the vast bulk of the campus has been up on College Hill. And that's where the vast bulk of our attention has been on our decarbonization strategy. But the growth in the JD is starting to take off now, particularly in the last 3 or 4 years. And right now we're planning a 300, actually it's in design, well into design, a 300,000 square foot life sciences building. And this was the perfect catalyst for us to say, hey, we haven't really paid much attention to decarb down in the JD. We need to do it. And then, you know, I'm kind of the king of half-baked ideas, and I'm like, I can't, you know, I can suggest all I want, but we need somebody professional to come in here and guide us through that process. So there are many opportunities, probably too many, and so we need to explore what's possible and what's best for Brown, and that's what this process started with. Let's go to the next slide. Just to give you an idea of the geography down here, that swath of sort of disturbed land that you see in the middle, this is sort of an older photo, but that's where Interstate 195 used to pass through, and you can actually see some bridge, the bridge supports over to the right from when the highway was there. That's now a beautiful pedestrian bridge. There's a lot of green space in there now, and that 195 land is being, you know, developed particularly for life sciences types of facilities, and also nice housing and things like that. The area that you see that's called the Central Hub, that's where our initial growth has been in the JD, and I'll talk about a couple of the buildings in a minute. And then over to the right, there's an old power plant which has been developed into, actually I'm sitting in that right now, it's sort of a multi-use office building. And then there's some other stuff and housing down there. So this seemed like an area that might be ripe for some type of district energy system, but do you involve other stakeholders? Do we just do it at Brown? Do we maintain it? Does somebody else? There's just, like I said, there's too many opportunities sometimes. Let's go to the next slide. And I think we have some building names on here that I can talk about a little bit. Well, not quite yet, but on here, there's different color-coded buildings or color codes for buildings. The ones that are in tan were sort of the existing buildings that we already had in the area, and then The red buildings are the ones that are either in design or we know we're going to build. We've also purchased those buildings in the lower right-hand corner. One of them is we're turning it into graduate student housing. Another is more office, and we're actually putting a Hafen-Reffer Museum in there. And then those in blue are potential other off-takers. So those might be, another life sciences building or something built on spec where there's multiple occupants. They need district energy might benefit them as well. The interesting part here is the three buildings that we're kind of focusing on, and Bob will get into this, but that tan building all the way to the left used to be the Spidell building. So if you bought a wristband 30 or 40 years ago from Spidell, it was likely manufactured in that building. We transformed it into a life sciences research building with a vivarium about 20 years ago, and it is our highest EUI building on campus and will be very difficult to decarbonize. And then the tan building to the right of the red blobs is our medical school, which was opened down there about 10 or 12 years ago. The big, large red building, that's where our large life sciences building is going, and they're well into design there. We should be doing site prep work any day now. So that's sort of some background. Like I said, there's so many opportunities down here for potentially using district energy for decarbonizing instead of doing it building by building. But again, the questions are, do we go big? There's actually a large power plant nearby. You can see there's a river. So there's all kinds of resources available. But what makes the most financial sense for Brown to decarbonize as quickly as possible without, losing our shirt? So I think next slide, I think, is Bob. Bob, you still there, I hope?
Yes, I am. Yep. I'm moving the slides, and it says my camera is still on, so I apologize for this. But now we'll get into this is the doing part of the process. We included this slide here. Strategy is important, but execution is everything. Incredibly successful people focus on executing incredibly well. So this is the framework that we use to execute incredibly well. It was a process where we gathered the key stakeholders and we held framing goal sessions to help define the key outcomes, and that ultimately led us on a few paths to figure out. We diverged to converge on potential solutions, and then we landed on our final solution. So key stakeholders, just looking at the key stakeholders, I'm sure everybody on the call is well aware that early and often, we like to say early and often, identify and get your key stakeholders around the table early and often. Collaboration is king, especially at this point in the process. So once we figured out the right team, we held framing goal sessions to align interest and build consensus around the most important outcomes we should be solving for. Here are the titles for the key stakeholders who were around that table. Can't say it enough about us focus the project and it builds alignment, and which builds consensus, which builds momentum, and really ultimately unlocks funding, because we have all of those pieces of the puzzle. So this is a very long list. There's a lot of titles here. I'm not sure how many other campuses that are on the call today or on the webinar today that would have this many, but there were a few of these titles that were very, very involved. They were really what we would consider the key champions, and then others like general counsel and the government and community relations. They were a part of it, but they weren't driving it as hard as some of the other key stakeholders. Very important. And then for the project objectives and criteria. After many meetings, very iterative process landed on solving for these most important targeted outcomes. This really became the lens our design engineers, JP and team, used to diverge on a few possible solutions and then converge on the one you'll see shortly. Now we'll get into technical solutions. JP?
Yep, thanks, Bob. Thanks, Dave, for the introduction. So now I'll talk a little bit about the different concepts that were on the table and that were evaluated to try to answer to the question, what is the best way to decarbonize the jewelry district for Brown? And so in a nutshell, three concepts were explored and developed. First one is to keep every building standalone. After all, the few buildings that are currently in the JD, although there's a lot of potential growth and planned growth, like Dave mentioned, but the current buildings are all standalone, so they all have their own boiler, heating, and cooling plant, and backup power when it applies. So we considered that was one potential pathway, and to electrify and decarbonize every building standalone moving forward. The second option, that's a little bit traditional, is to create some sort of a plant that's centralized, where heating and cooling would be generated and distributed through piping and distribution network to all of the buildings around. And the third option that we investigated is a bit of a new approach that on the market that we've seen in Europe and a few places in North America, and is a mitigated loop. So it's still a hydronic system that distributes energy across buildings, but at an ambient temperature. So not too hot, not too cool. And you'll see how that can be, along with other measures, be part of a decarbonization strategy. So if you switch to the next slide, you'll see, so here we're illustrating all three strategies for the core buildings of the JD for now. As you remember, there are other sectors in the neighborhood that where there's more buildings, but we're just illustrating the concept for a smaller group of buildings. In brown are the existing buildings, and the red are the future potential buildings. Some of them, the central one, which is the one that's directly in between the two brown buildings, is currently being designed. It's a new life science building, so that one is very real. But the two other red buildings, future, are still they haven't been approved yet or funded. So strategy one, let's install generation equipment to allow for decarbonization in every building. Strategy two, for that concept, next slide, you would see a central plant with hot water and chilled water piping distribution. In strategy three, you would see a mitigated loop that connects all buildings. And here, in every building, of course, you can't do much with the ambient water temperature directly. You can't heat or cool with it. However, you can exchange heat. And in an example like the jewelry district, where there's a wide variety of different building usage, a mixed use portfolio of buildings, that loop allows to transfer energy in between buildings that's unused or excess heat that one building may have, and it can be transferred to another building that may be in heat demand at some point. It also enables to connect to this loop, anywhere on the loop, some renewable energy modules, like the yellow block here that could represent any way to generate decarbonized energy. Could be ground source driven, it could be air source heat, river, or heat recovered from another site, and that can add heat to the loop. And of course, in every building, then you need its own infrastructure of boiler, heating and cooling equipment, as well as heat pumps that become very central to the concept. Heat pumps that can take the low-grade heat in the ambient loop, which is also here is called the 5th generation district energy system. and turn that ambient loop, low-grade heat into usable heat to heat building loads, and also reversely that the system can also dump excess heat from one building onto the ambient loop. Next slide, please. And here the phasing of the strategy 3 started to be very appealing to the stakeholders at Brown. You saw the long list of stakeholders, and the phasing, the scalability, the flexibility was a key driver in planning the decarbonization of the jewelry district, because like I mentioned, there's some existing buildings. In this case, if we zoom just on that part of the campus, we're looking at 3 buildings, 2 existing one that's currently in design will be built within the next 2 years. But they're not, all the other potential future growth buildings are not built yet. So if you were to go with a central plant approach, how big do you size the central plant from day one, knowing that your users may double or triple down the road? Same with the distribution piping. And so you start to quickly with strategy 2, you start quickly to run into flexibility and phasing issues when the bulk of your users are not there yet. Strategy 3 gives a lot more flexibility in that sense, and so you could see a phase 1 where this slide shows a phase 1 of strategy 3 with fewer buildings, and you're starting with a system that's a little bit more cost effective in the first few phases, and then as buildings get added, the system can be expanded, and without installing assets that will sit and underperform for or be underutilized for long periods of time. Next slide, please, Bob. So here we're showing the long-term vision of what could be a 5th generation. That's still strategy 3, 5th generation energy loop, with having actually 2 separate loops, because in this particular case, we found that there were maybe 2 hubs of buildings, and so one being more centrally around the main hub, and another one more down to the bottom and the right of the slide. So to have 2 separate mitigated water loops appeared to be a winning strategy from a life cycle cost perspective. And you see that, you see that the building types, we see medical school, life science, and on the central part, and lower and right, we see grad housing, along with some other use. So it's a diverse mix of buildings with energy needs that may vary in time, and that allow that make the sharing of energy something that makes sense. Next slide. And that's another potential avenue that we also considered, although it was determined that 2 loops was a little bit more cost effective, but it was also modeled to have one complete mitigated loop for the whole site, possibly connecting to other buildings up north. Next slide, please. And I think here it's just to show the amount of heat recovery that's possible. With this system, it allows more heat recovery than with another standalone approach, for certainly. And we've demonstrated that the new building, the new life science building, will have a lot of heat recovery potential. Will recover a lot of the energy in the exhaust ventilation, for instance, and it will be in a position to export energy to its neighbor buildings a lot of the times, and those can benefit from that heat. And finally, the next slide shows a comparison, and that's where we landed. Really, we were comparing those 3 strategies on the various criteria that you see on the top row: resiliency, flexibility, capex and opex, obviously that turn into life cycle cost. Land use was important because take using more land for a plant prevented or there was an opportunity cost for Brown University then they would not be able to use that land to build a new academic or life science building down the road. So that was very important to them. The flexibility, we talked about it. The resiliency was very key to the discussion. And Dave, you can also feel free to jump in and add on that slide things that any thoughts and observations that you remember from those discussions. But resiliency is a very central theme at Brown, and the fifth generation district, the scenario, the third approach, provided the best resiliency because every building kept its own heating and cooling infrastructure. So we keep the generation close to the loads. That was critical for the new life science building. But in addition to that, you could see import energy coming from surrounding buildings, and in many cases we were able to provide some useful heat with the mitigated loop directly. For instance, being able to preheat outside air, and so that provided some additional resiliency. Yeah, do you have anything to add on that slide?
Yeah, I mean, resiliency has really risen in importance to us. In fact, I used to be in the Office of Sustainability. Now I'm in the Office of Sustainability and Resiliency. We've hired a resiliency director, and so that was a key that folks were looking at. We have had, like I'm sure everybody does, some issues with our district energy system up on the main campus, and everybody wants, to have the ability to heat and cool, particularly when you have a critical life science research going on. You have a vivarium. You need that to be reliable and resilient no matter what happens. The other thing critically here is flexibility. There is so much growth in this area, I will say geographically, but there's also, growth in the knowledge of district energy, particularly fifth gen type systems in the United States, things we're learning from Europe. And, there is potential in the future that a district energy company could come in and install a larger district energy system, and it would be very easy for us to plug into that since we have very low temperature requirements. Very easy to plug and play. And same when we add additional resources. Those other buildings, we're going to build them. We've purchased the buildings that are the existing buildings on those sites, or one of them is a parking lot. We're going to have buildings down there in the future, and it will be very easy to integrate these onto this fifth gen system. So,
excellent.
Yeah, I think we've covered all those points.
Okay. Now on to IRA incentives. Dave, what was your approach to maximize IRA potential? And GP, I wonder if you could tell us your evaluation method for scoring each solution, and ultimately what was the recommendation?
Well, I think Brown, like everybody, understands about this much of the IRA and definitely needs help and assistance to figure out, what's eligible, what are the chances that we'll actually realize these incentives. We have a little bit of in-house expertise, not in my department, but there are some folks that have some knowledge, but we definitely are relying on outside entities to help us with that.
Let's go to the next slide, Bob. So we evaluated different generation technologies to maximize the potential for Inflation Reduction Act money, and we evaluated air source heat pumps as well as geothermal heat pumps, in addition to heat recovery. So first and foremost, maximizing the available heat that's there in the buildings, and that was the first phase really that was approved to move forward. Here we're showing kind of the second phase to fully decarbonize the district in the long term. And it's showing air source versus ground source. what was interesting is the life cycle cost of the geothermal versus air source. So geothermal, obviously, it's subsidized by the Inflation Reduction Act directly, so that provided a good subsidy amount. What we found, however, is that with the mitigated loop system, coupled with an air source system, we were able to demonstrate that the mitigated loop can act as a thermal storage property under the Inflation Reduction Act ruling, and therefore that the fifth generation loop could be considered thermal storage, which dramatically improved the financial performance of other solutions than geothermal. And so that's why right now we're going with a first step being heat recovery, and of course thermal storage being the mitigated loop that could fluctuate in temperature over time, whether the group of buildings have excess heat or not for a certain number of hours, or and air source could be plugged in as a second phase. So so that's if you switch to the next slide, I think there's another, yeah. And here, you know, we're really that was another slide that shows that the left column, heat recovery, was a no-brainer, right? We were using that for heat recovery, and that's really the recommended approach. On the far right, we see electric boilers that were evaluated for the high peaks. That was the best life cycle cost for the electric boilers. And in the middle, actually, that was a slide that showed the earlier consideration of various technologies. What would we pick between geothermal technologies, air source, heat recovery technologies, and even river heat recovery? And it was in that middle load of roughly 25% that we performed that deeper analysis. So which ones of those middle options would be picked? And the IRA had a big influence because it was a fifth generation ambient mitigated loop system that could be used as thermal storage. The IRA had a big impact on the potential subsidies for that system, and therefore air source could even though we're not going geothermal, we're still planning to have some good IRA subsidies with an air source approach.
Yeah, I think what this demonstrates is, I'm sorry, but I was going to say what this demonstrates is, you know, obviously you're going to do heat recovery. That's your best bang for your buck. That covers about 2/3 of our load. The electric boiler is for the last peaking, or in an emergency, if we have to turn on a gas boiler to supplement, we could. You know, we're trying to decarbonize under normal circumstances. If there's extenuating circumstances, we are going to have some standby ability. But that middle load was really where the decision needed to be made. You know, which way do we go? We could use river water, but there's, you know, definitely permitting regulatory issues. The geo exchange systems sounded good. We didn't have a lot of footprint, and actually we did a test well in the area and found that there was some advection. So, you know, the open loop might have worked a little bit, but, you know, some of the permitting and regulatory, remember this was a jewelry district. It's likely that some of the substrate is contaminated, so we'd have to be careful there as well. So that was where ecosystem focused a lot of effort and did a lot of engagement with the stakeholders to see, you know, what is the best solution for that middle load of decarbonization. Thanks. You can go to the next one.
Terrific. Okay. So now we need to figure out how we're going to pay for this all and operate and maintain it. Dave, if you could take us through how Brown, the thought process that went into figuring out how you were going to do this.
Well, I think you guys guided us through this. while we do have a decent endowment, we don't use that to construct decarbonization stuff. So we have to fund all this stuff. There was a chance that we could just say, have somebody else do this, and we just purchase the energy, right? I know a lot of our peers do that. It's a elegant way to get progress on decarbonization without a capital outlay. So we did consider different ownerships. Could we involve other off-takers to make it a sweeter package for a third party? When we look at operating and maintenance, if we end up having our own loop, this would be unique. We don't operate a 5th gen type system anywhere else. Our new life sciences building is going to be quite complicated, and then we're adding new stuff on for decarbonization. Do we want to have the O&M expertise in-house to take care of this? There's advantages to that, there's disadvantages, or do we want to sub some or all of it out? I mean, a lot of our chiller maintenance is done. We contract that out. Do we respond when there's a problem? Yes. Do we replace motherboards in them? No. So there's going to be the right balance for operation and maintenance, and so basically, ecosystem kind of guided us through a process where we landed on sort of an integrated system where we're doing a little of both, right? I think that's what we're trying to say here.
That's right, Dave. Yeah, and this, I can't stress enough like how much time went into this originally. Figuring out if Brown was going to pay for it out of pocket through capex, or if it would have been like a PPA type structure. So we spent a lot of time researching that, and there were a lot of moving parts from Brown's perspective too in figuring out their own money situation as well. With ILSB being in the Jewelry District, it was I think, correct me if I'm wrong, Dave, the largest amount of money spent on construction in Brown's history. So they were trying to balance their book, so to speak, and figure out, depending on the size of the project, would it make sense to go capex or through a PPA? A lot of discussions on that.
Yeah, and some of the key aspects that were considered to evaluate the ownership and operation approach were here: life cycle costs, including equipment maintenance and renewal costs, the cost of energy, of electricity, but also the results themselves of installing all that infrastructure is the decarbonization itself, the reduction of metric tons of CO2, and that's a real concern. I think in general in the industry, there's a lot of Brown is not alone in having dealt mainly with boilers and chillers over time, and even though heat pumps are similar technologies to chillers, there's still a learning curve to integrating and switching to a slightly different source of heat, and we've seen in the past projects where heat pumps are installed, and after a few years, because of perhaps the design or the installation that was not done properly, some of the operation teams were left a bit to themselves and decided to and sometimes those projects don't perform as well in terms of decarbonization, because the heat pumps can be simply turned off and not operated anymore. When you have backup heat, the boilers that can provide backup heating, I'm not talking about any specific project here. It's just something that can happen. And
it's happened here at Brown. I mean, we have two small heat recovery chillers that I'm constantly telling people, go clean the strainer so the thing will run. Yeah, it happens. So.
Bro, I forgot about those two small heat pumps. I wasn't even pointing at you, Dave. But this is something that we've seen in our experience at Ecosystem over a few decades. When you have when you have heat pumps, sometimes they don't perform, and the whole goal of installing them is to decarbonize. So all that to say that how to best support the operation and maintenance of that new equipment is critical to make sure that all these planning and design efforts pay off. And in the next slide, you see that that's a bit why Brown considered some various ownership and operating O&M structures. So either on the left side we see a Brown only CapEx and O&M approach. On the right hand side, fully outsourced, more in the form of a PPA. And that was also fueled by the special characteristics of the jewelry district, that there were potentially other off-takers that are not Brown, buildings that are not owned by Brown, that could have been part of a larger district loop owned by another entity, and Brown would have purchased energy. That didn't turn out to be the best scenario, but there are also some middle scenarios that were considered and still are, and that discussion is still ongoing. Brown hasn't landed yet on what's the very best way to operate and maintain those new heat pumps that will be introduced in their subsystem. So perhaps a hybrid approach where Brown has some operation and maintenance, but also has some support. And then the next step is to exactly define that support. What exactly does it consist of? How much does it cost? What's its value? And how do you quantify the value of that O&M support? That's really not seen at all in replacing Brown staff, but really providing them the right support so that they're the local on-site people that have access to their equipment, but there's some various interesting ways and cost-effective ways to provide support to make sure that these equipment run and deliver. Anything to add, Dave, or that's?
No, that sounds right. And it's really, it's the one thing with Brown risk, carbon maintenance, life cycle, OpEx. It's very important, particularly say to our Associate Provost for Sustainability, that we realize this carbon reduction, right? So if we, and we recognize the fact that if we do all this maintenance in-house, we're not gonna have the up hours that we would if we leaned on the right outside help. So, and when you only have one or two of a certain piece of equipment, you don't necessarily have the expertise. When I was in the Navy, we would have these, those folks that worked on every ship in the same class. They would come over and say, oh, well, you forgot this card here, because those of us on the ship were only on one ship, but they'd seen everything from 45 different ships, right? So we realize that that's important. We need to make sure that we realize the carbon reduction. So
that's right. We have one more section here, one more slide on market trends. JP and Dave, I'm wondering if you could quickly take us through this and maybe talk about some parallels you see with this project and some of the other projects that are going on throughout North America.
Dave, do I let you start, Dave? Or
I thought this was you, but
yeah, sure. But well, you told me last time when we talked about this that it's really the hubs approach,
Yeah, it's true. Yeah, I mean, I was going to say, I mean, the more I've seen other campuses that are decarbonizing, they're not doing everything at once. They're typically addressing, they're finding the easiest area to address first and get that foothold into decarbonize, and then find a way to leverage that to make progress. And I won't mention any specific colleges, but we're finding that that's exactly what we need to do too. We're doing the same thing up on College Hill with our main loop. Doing all this work down in the JD, all of the exploratory work, all the work engaging stakeholders, I think has benefited the work that we're doing up the hill as well, because we're noticing, hey, we don't necessarily have to have a central plant. We can distribute this around campus and sort of have a sort of a microgrid of heat, and and also do the same thing on the electric side. Adds to resiliency, reliability, so the more that we do this working on specific hubs, the more we learn, the more we can apply it to other hubs. Do something, right? Get to that first hub that you can address, take care of it, then leverage that to move on. I think that's what I was talking about the other day, JP. So.
Yeah. Thanks for repeating that live, Dave. And yeah, I think you're right. And we see that as well, ecosystem, and in some of the projects we participate in here. Some of them are named Georgetown University, Ohio State University, and U10 is an acronym to describe a project and a potential project in Manhattan, consisting of some commercial buildings. But in all three cases, we see examples where, like you said, the whole campus or the whole site is not decarbonized at once. Although that can be that can be the way to go sometimes, but it's not always realistic or possible financially for in every situation to switch an entire steam district system to hydronic, whatever the district approach is. And so starting with a hub approach, having a certain group of buildings that are still perhaps on the steam network, but interconnecting among them and fed by some heat pump technologies. So that's definitely a trend that we see in the market. That pays off in terms of having a better bang for the buck as a first phase to get moving and to start down the road to decarbonize. And that's certainly how the jewelry district is a good example of that. It starts small and can expand down the road. Although in this case, it's the expansion would be in future new constructions, but the example still applies.
That's great. In the final slide before Q&A, hope is not a strategy, but sometimes with the campuses that who we work with and who we speak with regularly, it's hope may be the only thing you have left and exactly what's needed to keep you going. So if you feel like you're lost or stuck on your path and we can help unstick you, please reach out. And that's with Dave too. If there are any questions that you think of, if there's anything that we might expand on outside of the webinar, please feel free to reach out to us if we could be of help in any way. Questions? Billy, do you have the questions?
I had to unmute myself. I apologize. Yes, we do have questions. First question, is it possible to clarify projected temperature ranges in the 5th gen loop and the mitigated loop?
Is it what?
The temperature. So we're looking at a 75 to 95 degree circulation temperature. So 5th gen is typically low temperature. I think it can expand outside that, but that's what we're looking at, 75 to 95.
Yeah, in normal operation. Yeah, that's right. But it could also fluctuate outside of those ranges for thermal storage. And yeah, we've called that active thermal energy storage. So ATES. There's if you Google that, an ecosystem, you'll find a link that describes it with a little bit more details.
Okay, thank you. Next question, heat recovery, 66% of the base load. Have you considered how long it will take to satisfy the demand for heating, or do you have other ways to support that demand, say heat pumps?
So I think the question is about anything above heat recovery. So that's where, first of all, by using heat recovery as the first, if that takes care of 2/3 of our heat, and it's easy to do, it's they call it the best bang for the buck. But yes, we're trying to fully decarbonize, and so that's where we need to plug in some other source of heat for those colder hours. And right now we're looking at potential for air source heat pump injection. There is a major sewer line running down the street. You know, we might end up putting a sewage heat recovery system in at some point. You know, down the ways, it may be that regulatory wise, going down to the river and grabbing some heat from that might work. Storage. I'm not sure if that answers the question, but that's the best I can do on that one right now. So.
It's good attempts.
Okay. Okay, our next question is there an estimate of how much load reduction will be observed at localized equipment as a result of adding a mitigated loop?
Yeah, of course that, yeah, we do have those, that model. It depends on what time of the year, at what outside air temperature. In peak conditions, like design day conditions, that's not when you will see the most sharing of energy in between buildings. Because if we go back to that central hub, or actually the first phase, we have one new building that's a life science, that's high energy intensive, but that also has tremendous, at least that's currently what the design suggests, it will have tremendous heat recovery capabilities, meaning that it will be able to recover a lot of heat in the exhaust ventilation. And so, of course, in peak design day, there'll still be more heat demand in that building than what it can recover, and it won't be able to export to its neighbors. But as the outside air temperature increases, there'll come there's an inflection point where the building becomes in excess heat. And so, to answer the question, that there's some times of the year where perhaps when it's I'm trying to remember the energy model here, but when it's you know, maybe 40, 45 Fahrenheit outside, the two neighbor buildings that are usually the recipients of the heat recovered from the central building will see their heating being 100% supplied by the central life science building. And of course, that answer varies depending on at other times of the year when it's a little bit colder, the buildings will see maybe 50% of their heating load provided by the central building. And then in very peak conditions, it's closer to zero. But over the year, it's a substantial amount of heat provided that's shared in between buildings. And down the road, it could also be some assets like electric boilers could be installed in one building and shared, their energy shared to other buildings. We could also see air source heat pumps installed in one central building, and that energy could be shared as well across the mitigated loop to other buildings.
Okay, thank you. Our next question is the modified loop similar to a heat pump loop with a varying temperature? And second part of that question is, do individual air source heat pumps supply 40°C water to individual zone heat pump loops?
So maybe I'll answer the second part, since maybe I understand it a little bit better. So the air source heat pumps would heat up the mitigated loop. So air source heat pump technologies are not yet, well, at least what we have on the market available. It's hard to make very high temperatures with that. So that's why air source heat pumps are extremely compatible with the mitigated loop. That's like Dave said, in the range of 75 to 95 Fahrenheit, which is relatively cold. So the air source heat pumps are meant when they're in heating mode to heat up the mitigated loop. And then in every building, there would be heat recovery heat pumps that would boost up the temperature and drawing energy from the mitigated loop, and then to supply, to offload their heat onto the individual building hot water loops. And that could be that could fluctuate depending on the building systems. So the new construction, of course, will have a low temperature hydronic loop of 120 Fahrenheit or so. However, the two existing buildings, one has a hot water loop that has that's designed to with a peak of 140 Fahrenheit, and the other one is closer to 160 Fahrenheit. And so each heat pump in the individual buildings can operate at just the required temperature. So you gain on efficiency by heating just to the temperature that you need, and not being dragged down by the weakest link or the building with the highest temperature required, as would be the case in a more central approach.
Yeah, and if I understand the first question, that yes, this is like an old heat pump loop in a building where you're circulating tempered water, and then the local heat pumps will boost it, either the cooling or heating as needed. Very similar, if I'm understanding the question correctly. That's what it's like. And then, like a traditional heat pump building, you would have a boiler or an electric boiler and a cooling tower. And really, our air source heat pump can function that way, or some of our exhaust heat recovery systems as well. So.
Okay, it looks like we have time for one more question, but I can let our panelists know we have more questions than we have time for today. So if we don't get to your question, please know that the questions will be sent to the panelists and they will reach out to you with an answer. And we will then, if we can, we'll put them into a spreadsheet and load them onto the website so you can see how these individual questions were answered. So we have time for one more. So can you provide a little more detail on how the heat pumps interact with the building systems? Are they tying into existing 4-pipe heating, cooling equipment inside the building?
Yes, that could be a good description of the configuration. If you have a building with an existing chilled water loop, so 2-pipe chilled water and two pipes for hot water, then the heat pumps could be tied to those two, and when they're in heating mode, you could see the heat pump connected on the evaporator side, so drawing its energy source from the mitigated loop and connected, dumping its heat in the hot water loop. And when you're in heat rejection mode, the heat pump could generate, could be connected on the chilled water loop on one side, drawing energy and dumping in the condenser, the mitigated loop. So hopefully I'll be able to provide a little bit more clear answer in the write-up.
Okay, thank you. Well, we have 2 minutes, so let's see if we can take one more quick question.
Right.
A real quick question. Does the loop include both heating and cooling?
So the loop interacts with both heating and cooling in building systems, in the sense that it can be used as a source of energy for heating one building, and it can also act as a heat sink to discharge energy from a cooling system. However, in order to be able to do heating or cooling, it needs there needs to be a heat pump that bridges the mitigated loop to either the heating or the cooling system inside a building.
Yeah, like in the summertime, we're gonna provide the heat needed for reheat and other loads, and we'll take we'll use that on the cooling side as much as possible, because that's the most efficient way if you're making cooling and heating at the same time. But if we need to trim with more coolings, there was that one graph where we had the heating and cooling loads, then we might use traditional chillers. So depending on the season, either the heat or the cooling load will define how much we use heat recovery chillers, and then how much we trim with the other. So.
Okay, well, gentlemen, thank you so much for this webinar. We're at the top of the hour, so we're going to sign off for today. But as I said, we will answer all questions today. So, gentlemen, thank you so much. I'm getting great emails with congratulations on a great webinar, and people are asking for the presentation, so I will be sending those out to everyone. And again, thank you so much for your time. And to our attendees, thank you much for taking time out of your extremely busy schedules to be with us today. So until next time, be safe, stay healthy, and let's be kind to one another. Thank you so much. Bye-bye now.
Thanks, Billy. Thank you.
Thank you, everyone.